Exploring beyond what we can see in the universe brings us to 5 fascinating ideas about what might be out there. What secrets might dwell beyond our universe's edge? Welcome to Revel Discovery. About 13.75 billion years back in time, a cosmic event of immense magnitude unfolded, giving birth to the universe as we understand it today. In the wake of this cosmic inception, an extraordinary burst of primordial light erupted, racing through the expanse of space and scattering its brilliance across the nascent universe. Simultaneously, the very fabric of space itself embarked on a journey of expansion, setting the stage for an extraordinary cosmic evolution. Yet, this expansion was not without its subtleties. In the aftermath of the initial burst, the inflationary frenzy that marked the early universe began to slow its pace. Nevertheless, a force previously unknown, now identified as dark energy, emerged as a silent architect, driving the universe's expansion forward with an ever-accelerating momentum. The cosmos embarked on a journey of growth unlike any other, a journey that has persisted since its origin, continuing to shape the universe's fabric to this day. The curious minds of physicists and mathematicians have dedicated centuries to unraveling the profound enigmas concealed within the vast cosmic tapestry. These luminaries of scientific inquiry have tirelessly probed the very nature of the universe, endeavoring to decipher its secrets and illuminate the shadows of the unknown. However, among these intellectual explorers, there exists a subset of audacious scientists who refuse to be confined by the boundaries of what's known. They boldly venture into realms of pure speculation, pondering what might exist beyond the universe we perceive. And so, we delve into 5 theories that arise from the daring minds, theories that tantalize us with the possibility of something beyond our universe, worlds concealed from our direct observation, and the mysteries that unfurl within the speculative domains. Before venturing into these theories, let's delve into the notion of the observable universe. This concept, a refinement of the ambiguous idea of outside the universe, stems from the fact that we can only perceive objects when their emitted or reflected light reaches our eyes. Thus, the extent of what we can see is bounded by the maximum distance light can traverse since the universe's inception. This distance leads us to the estimate that the observable universe spans approximately 93 billion light years, housing a cosmic menagerie of quarks, quasars, planets, and stars, all of which have documented by our diligent telescopes. Remarkably, the observable universe is a dynamic entity. It continuously expands as light from distant corners of the cosmos journeys to meet our gaze. This phenomenon inevitably raises the question of what lies beyond this ever-growing horizon. While we possess a limited scope of interaction with the universe, a boundary exists beyond which we can never peer. Still, astronomers harbor a notion, supported by a degree of uncertainty, that the expanse beyond this boundary is inhabited by an assortment of matter, energy, galaxies, and possibly even Earth-like planets. Speculation unveils the tantalizing prospect of encountering versions of our own planet Earth, bearing uncannily familiar attributes. Perhaps a world where you chose cereal over eggs for breakfast, or another where you skipped that morning meal together. This conjecture assumes that as we traverse farther from our universe's edges, we might encounter another Hubble volume, an entity identical to our observable universe, harboring alternate versions of ourselves and realities governed by the myriad choices we might make. The infinite nature of the universe invites contemplation. To this end, Einstein's theory of relativity asserts that objects in close proximity cannot move against one another at speeds surpassing that of light. However, this restriction does not extend to objects positioned far apart, a situation where the space itself can expand. Hence, the perception of objects moving faster than light arises from the expansion of space, a phenomenon responsible for the galaxy's outward drift from one another. Yet, reaching the elusive edge of our observable universe poses significant challenges. It demands either transcending the speed of light, an achievement currently deemed implausible, or navigating through cosmic shortcuts like wormholes or warp propulsion, concepts that too remain subjects of skepticism among physicists. Among the intriguing cosmic mysteries is the phenomenon known as dark flow, an occurrence discovered in 2008. Astronomers noticed an anomalous pattern, galactic clusters comprising thousands of galaxies exhibited synchronized motion in a specific direction, hurtling at speeds exceeding 2 million miles per hour. This dark flow puzzled the scientific community and prompted further investigations. Delving into this enigma, scientists focus on colossal structures, the giant galaxy clusters. These conglomerates, composed of galaxies and searing hot gas that emits X-rays, exhibit an interaction with cosmic microwave radiation. This interaction results in a temperature shift called the Sunyaev-Zadovich kinetic effect, which scatters photons from X-rays into the cosmic microwave background, or CMB, a remnant of the universe's birth. This effect was brought to the forefront by a team led by Alexander Kashlinsky at NASA's Goddard Space Flight Center, who examined around 700 clusters situated up to 6 billion light-years away. The surprising revelation was that the motion of these clusters contradicted expectations based on mass distribution models post-Big Bang. This deviation led scientists to hypothesize that immense structures lying outside our observable universe's confines exerted gravitational forces, influencing the motion of these clusters. It's a tantalizing notion that the universe's composition might not be uniformly distributed on grand scales, hinting at hidden structures and forces beyond our immediate sight. Infinity bubbles introduce another speculative avenue for contemplating the cosmos' outer reaches. Instead of envisioning separate universes, this theory conceptualizes a unified universe with pockets we are unable to observe. These pockets, formed during the universe's expansion, halted their expansion in tandem with the rest of space, giving birth to self-contained regions, bubbles, each existing with its unique set of physical laws and constants. However, traversing these bubble boundaries remains elusive due to the relentless expansion of space between them. Intriguingly, physicist Lee Smolin introduced the fertile universes theory, suggesting that every black hole birthed a new universe with subtly different physical laws. This concept of natural selection within the multiverse hinges on the prevalence of black hole formation, which dictates the course of universe reproduction. However, even Smolin himself later revised this theory, highlighting the complexity of navigating each speculative terrain. Parallel universes stand at the forefront of multiverse hypotheses, particularly within the framework of string theory. These theories delve into the enigmatic realm of higher dimensions and oscillating membranes, suggesting that the interplay of these multidimensional entities results in the birth of new universes. Astonishingly, these ideas propose that gravity, which governs our universe, actually leaks into our reality from another dimension, explaining its apparent weakness compared to other fundamental forces. In the end, these theories present an exciting web of speculation about the universe's bounds and its interactions with the unknown. While the pursuit of answers remains ongoing, it's essential to recognize that these theories, whether they find eventual confirmation or fade into obscurity, fuel the fervor of human curiosity and drive our journey to comprehend the cosmos. In the uncharted territories beyond the universe we observe, these theories stretch the boundaries of our imagination and hint at the vast complexity that lies beyond. While the mysteries remain, the pursuit of understanding propels humanity's ongoing journey to fathom the cosmos' true nature. So the question lingers, what lies beyond our universe? Are there realms uncharted and realities unseen? Do the concepts of infinity, parallel universes, and exotic forces hold water? Or are they merely flights of human imagination? As we gaze up at the night sky, let us marvel at the possibilities, embracing the grandeur of the cosmos and the boundless horizons of human thought. Engage with us by leaving a comment, subscribing to our channel, and clicking the notification bell for regular updates. Keep watching, stay inspired, and get ready for more exciting discoveries. See you in our next episode.